This is Unit 2, Lesson 6, More Properties and Proofs. In Lesson 1, we learned some properties that are essentially the rules of mathematics, and these explain and allow us to perform various actions mathematically, and making sure we're all operating using the same rules. In this lesson, we're going to be doing basically the same thing, except the structure of how we'll show it is a little different. This is kind of a window into geometry, where one of our major activities will be writing mathematical proofs. So that's what we're going to be doing algebraically. All right, so this is what a proof looks like. The instructions say, prove each of the statements are true by using an algebraic property in the reasons column. You can see this is the structure of what a proof looks like. On the left-hand column are the statements that will be given, and on the right-hand side are the reasons. Now, you can see the initial statement that's given in a proof is something that is our starting point, and so the reason for that is that it's just our given information. It's our starting point. Then what we need to do in the proof is say to ourselves, okay, what allows us to go from step 1 to step 2 and have it still retain the equality situation? Why were we allowed to do what we did that led us from step 1 to step 2? And when we figure out the property that allows us to do that, we write it as the reason in step 2. And then we say, how did we go from step 2 to step 3? The reason for that we put in the reason column for step 3. And we continue with the property to go from one step to the next all the way to the end of the proof. So before we continue, I want to tell you about one more property, though it's not really a property, but it's one of the reasons that you might have in your proof. And it could be that you've simply combined like terms to go from one step to the next. So there's not really a property for that, so our reason is simply saying simplification or combining like terms. You can use either of those interchangeably, and you can abbreviate by writing CLT. All right, so let's go ahead and try one. So here's our initial statement, and that's just the starting point, our given information. So the reason is already written in there for you as given. So we say to ourselves, okay, how do we go from step 1 to step 2? And you can see that that expression that's part of the right-hand side of the equation, 2 parentheses x plus 3, has been rewritten in a different form, 2x plus 6, and we used the distributive property to do that, and so our reason for that is the distributive property. Now, how did we go from step 2 to step 3? Well, this is a little bit different than what we've been doing because it's not a step that we normally do when we're solving, but you can see that what we did was we took the portion of that expression on the right-hand side, plus 6 minus 5x, and we simply rearrange the order, minus 5x plus 6. Sometimes people like to do this just to group the terms that they're going to combine. So we're allowed to do that because we know that swapping the order is okay for addition as long as the sign is kept with each term. And so the reason that we're allowed to do that is the commutative property. Now to go from step 3 to step 4, what happened? Well, you can see that 2x minus 5x has been combined to make negative 3x. So that's what I was talking about before, simplification or combining like terms is the reason we're allowed to do that. Going from step 4 to step 5, you can't really see as clearly what happened. We haven't really written it, the step that we've done, but you can see that what happened was we subtracted 6 from each side of the equation. And we're allowed to do that because the subtraction property of equality says that we're allowed to subtract the same value from each side, and it still maintains the equality. Now you can see that distributive property and commutative property up there don't say of equality, and that's because where that was happening was just on one side of the equal sign, just within the expression on one side, whereas this minus 6 is happening on each side of the equal sign, and so we need to say of equality in that property. Make sure you get that straight. All right, how do we go from step 5 to step 6? Again, you can't really see it written out, but what's happening is we're dividing each side by negative 3, and we're allowed to do that because of the division property of equality. And then how did we go from step 6 to step 7? Well, what we did is we just swapped the sides of each of those sides of the equation, and we're allowed to do that because of the symmetric property of equality. And that's our proof. All right, let's try another example together. We start off with some given information. That's our equation. So then we say, what are we doing to go from step 1 to step 2? Well, you can see that expression, negative 1/3 times x plus 12, has been rewritten in a different form using the distributive property. So that's our reason in step 2. To go from step 2 to step 3, you can see again we've rearranged the order of 2 of the terms, and we're allowed to do that by the commutative property. What happened between step 3 and step 4? You can see that those 2 terms, negative 5 and negative 4, have been combined into negative 9. That is simplification, or combining like terms. Again, you can abbreviate it CLT if you want. Then to go from step 4 to step 5, this one is not written explicitly, but you can see that we've added 9 to each side of the equation. The reason we're allowed to do that is the addition property of equality. Don't forget to write of equality. To go from step 5 to step 6, we have multiplied each side of that equation by negative 3. As long as we're doing it to both sides of the equation, it still maintains the equality, and the reason for that is a multiplication property of equality. And that's it. All right, example 3. You give it a try. So pause the video at this point in time, write out the reason for the proof, and then check in again and see how you did. All right, let's take a look and see how you did. All right, give example 4 a try and then come back and check on that one. All right, here are the answers to number 4. Now try number 5. All right, here are the answers to number 5. And one more. Give number 6 a try. And here are the answers to number 6. That's it. See you in class tomorrow.